After months of teasing us, Mars has finally taken center stage in the night sky for sky watchers all around the world. Last Tuesday, October 6th, the red planet was closer to Earth than it will be at any time until 2035. On Tuesday, October 13th, Mars will officially reach opposition and maximum brightness in the sky. In the interim, virtually any size of telescope will be able to show you Mars's ruddy colored disk and even some surface features. Let's break down exactly why all this is happening by looking at a top-down view of the solar system from above. I've enlarged Earth and Mars for clarity. They won't be that close together to one another. And note that from above the plane of the solar system, the planets orbit the sun in a counterclockwise direction. So Mars's orbit, which is brown here, has an orbit that is about 50% farther from the sun on average than Earth's is. That causes Earth to complete an orbit of the sun more quickly than Mars. In fact, the Earth circles the sun almost twice in the time it takes Mars to complete one orbit. If the planets are placed at the same starting line on an imaginary racetrack around the sun as they will be at opposition as shown here, then when Earth returns after one lap, which I'll just advance to 1 year from now, Mars ends up on the other side of the sun. When Earth has completed its second lap, 2 years from now, the two planets are closer together, but it actually takes another couple of months before they line up again. And actually, to be precise, Earth and Mars pass each other about every 2 years and 50 days. Let me just put this back to now. Now there's an extra twist to all of this. Because Earth's orbit is fairly circular, while Mars's orbit is much more elliptical. You can see in this view that the sun seems to be offset from the center of the brown orbit. In fact, Mars's distance from the sun varies between about 207 and 249 million kilometers, or about 20%. And every 15 years or so, the geometry works out that we pass Mars while we are near aphelion, our maximum distance from the sun, and Mars is near perihelion, its minimum distance from the sun. When that happens, our two planets end up much closer to one another. That last happened in July of 2018. This month's encounter is almost as close, and it won't repeat again until September of 2035, when Mars will be near its perihelion when they meet at opposition. Now, during the summertime, the sun climbs very high in the daytime sky, so it holds the moon and the planets low in the nighttime sky. And during winter, this flips around, putting the planets nice and high, where we can view them more clearly through a much thinner blanket of Earth's atmosphere. But in spring and autumn, the planets are medium high in the sky. And this opposition is happening during October, so Mars will climb to about 50 degrees elevation for mid-northern latitude observers. And that's ideal for telescope viewing. Back in July 2018, Mars reached only about 21 degrees above the southern horizon. That was too low for clear views. Plus, the entire planet was engulfed in a dust storm that hid the surface from us. And these earlier sunsets in autumn also means that Mars becomes nicely visible earlier in the evening sky. Let me show you another diagram. So this is the same sort of view, but now showing more details. Now, each radiating white line represents an opposition. I've indicated where the planets are low in the sky and when they're high in the sky. So the oppositions in this sector will mean the planets are low, and in this sector will mean that they're nice and high. The perihelion points are marked with P's. So here's Earth's perihelion point, which occurs in January of the year. And here's Mars's perihelion, which occurs for us in the summertime. The dates around the perimeter on the green line are showing where the sun is on the ecliptic. So in February, the sun is here and so on. Now this year, this is our current opposition on October 30th, 2020. Earth and Mars are meeting about 2 months after Mars passed its perihelion point. And so the zone that they're in right now is where the two orbits are diverging. They're getting wider and wider as they go. And for that reason, Mars was actually closest to the Earth on October 6th, but only becomes aligned with Mars and the Sun at opposition this week on Tuesday. Now, during the early hours of Tuesday, October 6th, Earth and Mars were only 62 million kilometers apart. That amounts to about 0.41 astronomical units. An AU is the mean Earth-Sun distance apart. It also equates to about a 3.45 light minutes distance apart. So a radio signal from Earth to Mars or back would need one-way time of 3.5 minutes to get there. Now, viewed in a telescope around that close approach, Mars's maximum apparent disk diameter peaked out at about 22.6 arc seconds. And for comparison, Jupiter's disk is about twice that at 44 arc seconds. Now, on October 13th at opposition, Mars will be a little farther away at 62.7 million kilometers or 0.419 AU and about 3.5 light minutes equivalent. A year from now, Mars will be on the far side of the Sun, as I demonstrated a couple minutes ago, and it'll be 393 million kilometers from the Earth, or 21 or almost 22 light minutes. So that's quite a large distance, and that's the reason why we usually send space missions to Mars around the opposition times when the light travel time for radio signals is so short. Now, the next opposition to Mars is going to happen here on December 8th of 2022. At that point, the planet won't be quite as close to Earth, as you can see, but it will be a point of the year where the planets will climb nice and high in the sky, ideal for telescope viewing. But the next really close approach of Earth and Mars will happen on September 15, 2035. So they'll have to cycle about every 2 years around the loop until they get to 2035 when they'll be here at opposition. But the closest one that everyone will be waiting for is the next big one is October 14th, 2050. At that time, we'll only be about 56 million kilometers away or about 3.1 light minutes delay for the Earth-Mars distance. Unfortunately, being in the summertime, the Mars will only climb to about 25 degrees above the horizon for mid-northern latitude observers, so not ideal. So let's look at how to find Mars in the sky. So I'm using the David Dunlap Observatory to view the sky, but the same view will be seen by anybody in the GTA and at similar latitudes around the world. So let me just advance the time here to a little bit later, get the sun to come down, and we'll just bring the... So Mars is actually rising about 7 p.m. local time. But you might need to delay looking for it until it's climbed higher than the trees or buildings in your neighborhood. So say around closer to 9 o'clock before it gets nice and high for viewing. Mars will actually climb higher through the evening. I'm just going to throw on the constellations here so you can see where it is. Mars is sitting in Pisces. And as I advance the time, Mars will climb a little bit higher. It'll actually reach its highest point in the sky over the southern horizon after midnight at about 1 o'clock in the morning, maybe 1:30 in the morning or so. And then if you keep going, if you want to be an early riser or stay up all night and enjoy Mars madness all night, you can even wait and look for Mars just before it sets, before dawn in the western sky. You can see the sky is going to get light here. Around 6:30 in the morning, you should be able to see it, if you especially have no trees in the way. All right, let's go back to Tuesday evening. You notice that Mars is sitting near the stars of Pisces, a V-shaped constellation of Pisces. Mars is actually moving in a retrograde motion right now. That's because the Earth is passing it on the inner track of the solar system. And if you were to carefully note the position of Mars compared to those stars night by night, you notice that Mars will creep a little bit to the west or to the right of those stars night after night after night. But it's not something you're going to see heading out on a single evening. Now, don't worry if you miss seeing Mars on opposition night, because Mars will remain easily seen in the sky on every clear night for the next number of weeks to come. It'll be rising about 5 minutes earlier every night, so it'll slowly, gradually shift into the western sky, but it'll remain visible, although much, much dimmer and smaller, until the end of May next year. Now, while it does that, Earth is actually traveling away from Mars, so that will mean that the planet will shrink dramatically in its disk size at telescopes and in its visual brightness. But it'll also become better placed for evening observing because it'll be rising a bit earlier each night. So even by the end of October, you'll be able to see Mars nice and high in the evening sky several hours earlier than it is right now. Now let's look at Mars through a telescope. So heading back to my other app here, I'm just going to bring up a view of Mars as seen in a telescope. So even good binoculars, you might be able to see that Mars is a little round disk, but if you can get your hands on any size telescope, you'll see it much, much more details on it. Now, Mars's rotational period, or its day, is about 38 minutes longer than Earth's, and so by viewing the planet over many nights, you can actually see all the different parts of Mars's globe, its surface. In fact, if you looked at Mars at the same time every night, it would take you about 41 days to see see Mars complete one full rotation. But since we start by seeing a half hemisphere at any given time, and we have many hours of darkness during the night in October, you could look at Mars starting in the early evening at 8 or 9 o'clock, and then check in again with your telescope before it gets too low in the west at 5 o'clock in the morning, and you'd already see about 3/4 of the planet's globe in a single night. But generally within a couple of weeks of heading out into the evening, you should be able to pick up every aspect of the planet. Now on October 13th, as shown here, that's Tuesday night, Mars will display its southern polar cap, which is shrinking right now, so it's might not be all that apparent in your telescope. Generally, it should look as a small bright white spot near the edge of the planet. You want to look for the sort of dark region that's girdling the middle of the planet. So we've got regions called Terrana Terra, Cimmeria Terra, and Serenum Terra running across the middle of the planet, and then lighter toned areas such as the Amazonas Planitia up here, Elysium up here, and around them like that. After midnight local time, the dark wedge-shaped Syrtis Major Planum region will sort of rotate into view, and among some other things. And the lighter-toned Hellas Planitia region will join it. Now, these dark areas are actually exposed granitic rock, dark basaltic rock. On the moon, we would call those Maria. Some people call them Maria on Mars. Some people call them Terra, as you can see on this labeled image. The lighter areas on Mars are generally the same kind of rock, but they've been coated with wind-blown sand and dust, which is a lighter color that gives us the contrast between the dark and light. Now, this view of Mars will remain about the same all week, but don't forget that your telescope will probably flip Mars upside down from this view and/or mirror it left to right. And if you've got a large telescope, you could even try to see one of Mars's moons. This is Phobos in this view. The trick there would be to hide Mars just outside your eyepiece's field of view. So you need an app or software to tell you where Phobos would be compared to the planet. I can actually pull back and show Deimos as well. Deimos is a little farther from the planet, so it might be a little bit easier to catch it. But it's tricky. You can try, though. A few more observing tips. So when viewing anything in a telescope, be patient. Look continuously and wait for the moments of sharp clarity when the air settles down. You could try some colored filters if you have any. Some telescope eyepiece kits come with colored filters, and some of them will enhance Mars. For example, the number 23 light red filter can enhance dust clouds. The number 25 red filter can enhance the ice caps and some surface features. The number 47 violet filter can show clouds if there are any. And the light green can show Mars's ice caps better. And a number 58 green filter can show the ice caps, clouds, and dust storms. So experiment with different combinations and see what works best for you. If you're finding that Mars looks too bright and washed out in your telescope, You could try using a moon filter to reduce the glare, or just reduce the telescope's aperture by using the moon lens cap that most telescopes come with. So Mars will look terrific on every clear night. So take every opportunity that you can to view this rare event and relax. You've got several weeks to see the planet at its best. And if you capture any images of Mars on your camera or your smartphone, be sure to share them on social media. In the meantime, keep looking up.